In this video, we want to solve some equations in the complex numbers. These equations are a little tricky. The first equation is this. If z plus 1 over z equals 1, then find z to the 3 and absolute of z. First of all, note that we are not asked to find z. We are asked to find z to the power of 3. So there should be a reason probably behind this. Why we are asked to find z to the 3, not z. Keep this in your head. When we see this equation, the equation is z plus 1 over z equals 1. We notice that z is in the denominator, and we don't like to have rational expressions. To get rid of z from denominator, we multiply left side and right side of this equation by z. If we multiply left side of this equation by z, then we have z to the power of 2, z to the power of 2 plus, if we multiply 1 over z by z equals plus 1 equals z. So how from this we got to this? We multiplied left side, all the terms in the left side by z. Z times z is z2, 1 over z times z is 1. And right side times by z is this. Now, if we move z to the left, we have a quadratic equation. By moving z to the left, we get to this equation, z to the 2 minus z plus 1 equals 0. Now, maybe at this moment, you are thinking to solving this equation. You have a quadratic equation, so you can use quadratic formula to find z from this equation. But if you try to find z with the aim of quadratic formula from this equation, after that you have to raise it to the power of 3. And if you use the quadratic formula, you will see that at the end the solution would be something like this. 1/2 plus minus radical 3 over 2i, something similar to this. And if you want to raise this to the power of 3, it's so hard. At least it needs lots of calculation. And attention, again I have to mention this. We are not asked to find z. So there is no reason to find z. We want z to the 3. But how we can find z to the 3 without finding z? Because maybe you think always if we want to find z to the 3, first we need to know z, then we raise it to the 3. No, please pay attention. Let me remind you an important identity. That identity is this. A to the 3 minus b to the 3 is, or a to the 3 basically plus b to the 3 is a plus b times a2 minus ab plus b to the 2. For minus also we have, if here is minus, here it would be minus, here would be plus. For a to the 3 plus b to the 3, we can write it in this way. And based on this identity, what is z to the 3? Based on this identity, what is z to the 3 plus 1 to the 3? Based on this identity, this equals to z plus 1 times by z to the 2 minus a times b, z times 1, z, b to the 2, b is 1, 1 to the 2, 1. Now, please pay attention to this. This expression is exactly this, which we have here, and it equals to 0. So, if we multiply left side and the right side of this equation by z plus 1, then this left side, when we multiply it by this, we are going to get z to the 3 plus 1. And then it's easy to find z. Let me show you. So here at this moment, I know it's not easy. I told you at the beginning, this is a tricky question. So here we multiply left side and the right side of this equation. So we multiply left and right side of this equation by z plus 1. So we multiply both sides by z plus 1. When we multiply left side by z plus 1, based on this identity which we have here, z plus 1 times z2 minus z plus 1 is this. So for the left side we have z to the 3 plus 1. 0 times z plus 1 in the right side would be 0. So from here z to the 3 equals -1, and this is the answer that we were looking for. Find z to the 3, z to the 3 is -1. What about absolute of z? For finding absolute of z, simply we take absolute from both sides of this equation. So we take absolute from the left side and we take absolute from the right side. Absolute of -1 is 1. And absolute of z to the 3, please pay attention to this. Absolute of z to the 3 is the same as absolute of z to the power of 3. This is one of the properties of absolute value in the complex numbers. So absolute of z to the 3 is the same as absolute of z to the 3. And this equals 1. So absolute of z to the 3 is 1. So then from here, if absolute of z to the 3 is 1, what would be absolute of z? Attention, absolute of z is not imaginary number, is not a complex number. It's just a real number. Absolute of any complex number is the distance of that complex number from the origin. It shows just a positive number, greater than equal 0 number. So absolute of z to the 3 is 1. So what is absolute of z? By taking cube from both sides, absolute of z is 1. Now we know what is z to the 3 and we know what is absolute of z. Now look at this equation. Solve the equation z to the 3 equals I, and no polar form and no exponential form we are allowed to use. If you are familiar with polar or exponential forms, you know that probably. You can find z by converting I to the polar form or exponential form and then finding the solution of this equation. But at this moment, we want to solve this equation without any polar or exponential form. But how? If you are thinking to take a square root from both sides and then say, okay, z equals plus minus radical I, yes, you can say this. But what is radical I? For this reason, we solve this equation in a different way. Z is our unknown. Z is a complex number that we are looking for and we want to find z. So we suppose z, which we are looking for, as x plus iy. We don't know what is z, but we know that any complex number can be written in this form. Any complex number z is x plus iy. Now we substitute this in this equation for z, and then we try to find x and y, and then we have z. If we substitute this in this equation, then we have what? Then we have x plus iy to the power of 2 equals I. If we raise this bracket to the 2, it would be x2 minus y2 plus 2x yi. 2x yi, it should be equal to I. How from this we can get this? Simply multiply x plus iy by x plus iy, or use an identity. Then simply by multiplying this by this, x times x would give you this. Iy times iy would be i2 y2, and i2 is -1. So i2 y2 would be -y2, and so on. Simply multiply the bracket by itself. Now we compare real part in the left side with real part in the right side, imaginary part in the left side and imaginary part in the right side, and then we can find x and y. In the left side, this is the real part, and this is the imaginary part. Real part of the left side is x2 minus y2, but in the right side, what is the real part? We don't have any real part. When we have I, it is 1i plus 0, and real part is 0. So we don't have any real part in the right side. So x2 minus y2 should be equal to what? 0. But 2xy should be equal to 1 because the coefficient of I here is 1 and the coefficient of I here is 2xy. So 2xy should be equal to 1. Now we have a system of equations. Two equations with two unknowns. How we can find x and y? It's very simple. We start from one equation, we substitute in the other one. From the first equation here, we have x2 equals y2. Simply move y to the 2 to the other side. x2 equals y2, or y2 equals x2 is the same. And from this, y equals plus minus x. Now we substitute this y in the second equation. But for y we have two choices. Y is either x or negative x. First, let's suppose y equals x. Then let's see what happens. If we suppose y equals x, so we suppose y is x. So we replace this y with x because y equals x. Then we consider the other case. If we suppose y equals x, then this becomes 2x times y, but y is x, so 2x times x, it would be 2x to the 2 equals 1, and from here x2 is 1/2, and so from that we have x equals plus minus 1 over radical 2. But we know that y is the same as x, so if x is 1 over radical 2, or if x is negative 1 over radical 2, y is also the same. Now we have the value of x and y. But what about the other case? Don't forget, we have the other case. Y can be equal to negative x. If, please pay attention, if y equals negative x, and we replace this y here with negative x, then we have 2x times negative x equals 1. Then we have negative 2x to the 2 equals 1. And from here, x2 equals negative 1/2. But we know that any real number, attention, x is real, z is imaginary, z is complex number. Any real number to the 2 cannot be equal to a negative number. So this means that we have no solution for x, and so no solution for y in this case. So from these two cases that we had here, y can be only equal to x. Y cannot be equal to negative x. So the other case, for the other case, we have no solution. So finally, the only solutions for z, which we were looking here at the beginning, are these solutions. Z equals to plus minus 1 over radical 2 for x. So basically we have two solutions for z. 1 over radical 2 plus 1 over radical 2 I. When x is 1 over radical 2, y is also 1 over radical 2. The other case, the other solution is negative 1 over radical 2 minus 1 over radical 2i. If x is negative 1 over radical 2, y is also negative 1 over radical 2. So these are the two solutions for this equation. Here we have another equation. Find z from this equation. Absolute of z minus 2z equals 3 minus 4i. Here we notice that we have absolute of z. Let me remind you what is absolute of z in the complex number. When we have a complex number in the form of z equals x plus I y, absolute of z is basically s square root of x2 plus y2. This is the definition of absolute of a complex number. Probably you are familiar with this at this moment. Now we substitute these in this equation. Absolute of z, so we substitute absolute of z with this. So s square root of x2 plus y2 minus 2z, so minus 2 times x plus I y should be equal to 3 minus 4i. And now From this equation, we have to try to find x and y, and then we have the value of z. For finding x and y, we separate real parts and imaginary parts, and then we set corresponding parts equal to each other. In the left side, if you pay attention, we have radical x to the 2 plus y to the 2 minus 2x. All of this is the real part. And also in the left, we have minus 2iy or 2yi equals 3 minus 4i. Now compare real part in the left with real part in the right, and imaginary part in the left with imaginary part in the right. What is imaginary part in the right? -4. So this is imaginary part in the right. What is imaginary part in the left? Imaginary part is the coefficient of I. And here we have -2iy, which we can write it as -2yi, which is more clear that then -2y is the imaginary part. So let me replace this -2iy here with -2yi. -2yi. Now we set imaginary part equal to imaginary part, and then immediately we can find y. So here we have -2y equals -4. And what is y from this? Y equals 2. Now that we have the value of y, we plug in this value and we can find x by setting real part equal to real part. What is real part in the left? In the left side, we have this as the real. Radical x2 plus y2, but y is 2, so 4. 2 to the 2 is 4. Minus 2x should be equal to what? Should be equal to 3. For finding x from this equation, we can move 2x to the right and raise both sides to the 2. So we keep radical in the left and we move 2x to the right, or we add 2x to the both sides, raise both sides to the 2. Then we have x2 plus 4, 2x plus 3 to the 2, 2x plus 3 to the 2. If you multiply 2x plus 3 by itself and multiply the two brackets by each other, or if you use an identity, then 2x plus 3 to the power of 2 would be 4x to the 2 plus 3 to the 2, which is 9, plus 2 times 2x times 3, which would be 12x. From here, if we move x2 and 4 to the right, we have 3x to the 2 plus 12x plus 5 equal 0. For finding x from this equation, we can use quadratic formula. Based on the quadratic formula, x equals -b, -12 plus minus radical b to the 2 would be 144, minus 4 times 3 times 5 would be -60, divided by 2a would be 6. So finally x equals -12 plus minus radical 144 minus 60 is 84, all over 6. For a square root of 84, you can write it as 12 times 7. 12 is 4 times 3, so basically we can write this as -12 plus minus 3 times 4 times 7 all over 6. The only thing that we can bring out of the radical is 4. A square root of 4 is 2. So x equals -12 plus minus 2 radical 21 divided by 6. If we divide numerator by denominator, x equals to Negative 12 over 6 is negative 2. 2 divided by 6, we can cancel a 2 from numerator with denominator. Then we have plus minus radical 21 divided by 3. So this is the real part and this is the imaginary part of z. Between these two answers that we got for x, negative 2 plus radical 21 over 3 and minus 2 minus radical 21 over 3, the one that is with negative should be rejected. So pay attention. We got two answers for x, negative 2 plus radical 21 over 3 and minus 2 minus radical 21 over 3. This is obvious that this number is a negative number, but this one is bigger than 0. If x is negative number, this can't be a solution for the equation that we started with here. Please pay attention, this is really tricky. X here in this equation, if x is negative 2 minus radical 21 over 3, then that x would make this side of this equation negative. But in the left side we have a radical that is positive. So it cannot be a solution for this equation and should be rejected. So for z, only we have one solution. Remember, z was in the beginning. X plus iy. What is x? X is only negative 2 plus radical 21 over 3. And y is 2. So y is 2 times I. So plus 2i. This is the only solution of this equation that we had. I hope you enjoyed this video. If you like this video, please subscribe in my channel and see you in the next videos.